Hello students, welcome for the another video lecture for the MDM subject Introduction to 3D Printing Technologies. Now in this video we will discuss about the unit number 2. So the unit number 2, it is for design for the 3D printing. Now let us discuss the contents for the unit number 2. So the first is introduction to the concept of design for the additive manufacturing, which is called as the DFAM. So design for additive manufacturing. Actually, it is a set of methodologies and principles aimed at optimizing designs to leverage the unique capabilities of additive manufacturing, commonly known as the 3D printing. So it is dealt with the methodology. What are the key principles of this DFAM? Complexity for pre. We already discussed that the additive manufacture allows for the creation of the complex geometries without additional cost. These include intricate internal structure, lattice structure, and organic shapes that are not feasible with the traditional manufacturing methods. Material efficiency. So DFFM promotes the use of material only where it is needed, reducing the waste. This can lead to lighter and stronger parts through the techniques like topology optimization. So material efficiency can be achieved using 3D printing. Complexity for pre can be achieved using this DFFM, AM. Customization and personalization, it allows for the customization where each product can be tailored to individual specification without significant cost increase. Reduce assembly, it integrates multiple components into a single part, reducing the need for assembly and improving overall product reliability. Then functional integration, by incorporating multiple functions into a single part, DFAM can enhance product performance and reduce the need for additional components. Okay, so these are the three principles for the DFAM. In summary, these DFAM it provide us that means the complexity for for the 3D printing. The complex geometries complex models can be printed using this 3D printing. So it provides certain it provides certain informations regarding which parameter to be selected for complexity design. Material efficacy. So it also help us to put the parameters such that the materials can be saved. We can customize and personalize the model. So in that case also it also help us reduce assembly. That means the where the multiple components are to be assembled. So how these components can be integrated. So that can be helped by DFAM. And functional integration. So whenever we have a single part can have multiple movements or multiple functions, so that can be incorporated using DFAM. Now, what are the considerations? So first of all, we have to consider the material properties. Before starting any 3D printer, 3D before printing any 3D model, we have to we have to think about its material properties for the strain, flexibility, and thermal properties. Okay, suppose structure. When we are designing this, the 3D that is the 3D print, when we are using this 3D printer, so we have to consider about the support structure, okay, needed during the printing process, which may need to be removed post printing. So whenever we are putting the 3D model, we are taking that into the 3D printer software. So we have to think about this support structure, orientation and build direction. So this is also very important because in orientation and build direction, it help us to it help regarding the stain, surface finish, and support. So in that case, we have to think about this orientation and the build direction. Post processing, steps such as surface finishing, heat treatment, and removal of supports need to be considered during the design phase. So whether our 3D printed parts will need the post processing or not, that we have to think before printing any 3D printed part. Tolerance and feed. Achieving the desired tolerances and feed can be challenging with AM, requiring careful design and possibly post processing to achieve the precision. Tolerance and feed, these are related with the metrology, so that we have to consider before during the design stage. Okay, these are the considerations for DFAM. Then how this DFAM workflow? So that is just similar to the step that we are discussing the unit number 1. We have to design concept. So we have to start with the end use application in mind, considering the unique advantages of AM. So first is the idea. Second one is CAD modeling. Using any CAD software, you have to create detailed 3D models incorporating complex geometries and optimized structure. Then after that, we can do the simulation and analysis. Now, why this is required? Because Performing the simulation, it ensures the design meets structural and thermal requirements. So simulation, it is very important. Simulation help you to get the various type of the conclusions for your 3D printed parts. Prototyping means what? It is just to get the part to validate the design and necessary adjustment before printing the actual parts or final parts. So before printing any final parts, you can just print the prototype of that particular 3D printed 3D model. Then final design. Once you are uh, that means you are satisfied with the simulation analysis and prototype of your model, then you can go for the final design and the production. Okay, so these are the DFAM workflow for the additive manufacturing. Now, the general design guidelines. So, understand the technology, familiarize with the specific 3D printing technology. So, before starting the printing, which type of the 3D printing technology we can use, that we have to use, we have to think about that. That we'll discuss in the next unit. So various types of the 3D printing technologies are there: FDM, SLA, SLS, etc. Then minimize overhangs, reduce the overhang to minimize the support structure. When your 3D model is having the overhang greater than 45 degrees, so we require the supports. So this extra material is required to support your model, and this takes your filament. So to save this filament or material, you have to check whether your model is having the overhang less than 45 degrees Celsius. Okay, if it is greater than 45 degrees, then we require the supports. So incorporate angles, the less than 40 degree to avoid the supports. Okay, so that is given here, 45 degree angles. So it is overhang should not be greater than 45 degree. If it is less than, so we can avoid the support. Optimize parts orientation, adjust the orientation for the staying service. Now, if you see now this part, okay, you can't print this part something like this. You make it opposite because so this will be the best orientation for your parts. So this is not the correct orientation. You print it something like this. This is not the correct orientation, so you print something like this. So this is the correct orientation. So again, this is the okay. This is the same one. So we can print it, but in this case, the overhang you have to check. This overhang should not be greater than 45 degrees. Otherwise, it will take here the supports. Okay. So that means if you take here like this, so this angle should not be greater than 45 degree. Otherwise, it will take here the supports like this in the 3D printing. Okay. So that we have to consider. Okay. Then uh, guidelines for designing the parts optimized for 3D printing. So wall thickness. So the wall thickness should be in between 0.8 to 1 mm. So wall thickness 0. So that cannot be considered because it is the wall thickness 0 means it has nothing. Wall thickness of 1 mm. So that can be considered. So it should be in between 0.8 to 1.8 mm. The fillets and chambers. So use fillet and chamfer to reduce the stress concentration. So in this case, the stress concentration will be more. The chances of the breakage is there. So use fillets and the chamfers here. Hollow structure, design parts with hollow sections and internal lattice structure to reduce weight and material uses. When you are printing something, so what you do? We can fill the material from 0% to 100%. So 0% means it is completely empty, and 100% means it is filled with all the material. So that point you have to consider during the printing of the 3D model. Layer adhesion. So consider the impact of layer orientation on the strength, especially for the vertical layers. So printing the vertical layers. So vertical layers may be that means it is something. Let me check here what has happened. So vertical layers may be weaker. Okay, so they have given here the vertical layers may be weaker, something like this. So vertical layers may be weaker. Uh, so so here what we have to consider here, the layer adhesion. Layer adhesion means the layer, the first layer, the second layer, third layer. So the first layer must get properly added to the print bed. So this is the print bed, and this is layer. So the layers must be get properly added to the added to the added one by one. Okay, so that is called as the layer adhesion. Okay. Then functional design, the features. So incorporated tolerances, design with appropriate tolerance and clearances based on the accuracy of the 3D printer. So we have to check the dimensions properly. Assemble and modular design parts for easy assembly. We have to consider designs for large complex. Consider modular designs for large or complex parts. So in case of assembly and assembly of the different parts, we have to consider the proper fits, okay, and the tolerances. Material specific guidelines. So we have to choose the specific material that will provide us the strain, flexibility, and heat resistance. Surface finish. Design for the desired finish, considering the capabilities and limitation of the chosen 3D printing technology. So for surface finish, we can get it for after post processing also, or the parameter that we are providing in the 3D printer. It also provides us the good surface finish. Design post processing. So support removal. So design parts to facilitate easy removal of that means after once you print your 3D printed part, the support material can be removed easily. So we have to design it something like that. Post processing steps, consider any additional post processing steps such as sanding, painting, heat treatment in the design stage. So this type of the treatments we can use for post processing. We'll discuss this in details in the coming slides. Then software tools. Use design software. So we already discussed for creating the 3D model. You can use any type of the 3D printing software. You can do the simulation and analysis using any software. The ANSYS or ANSYS software or APM. You can take that one for simulation and analysis. Slicing software. So every printer is come up with its own software. So we can use that software and we can provide the different types of the parameters into that particular software. Okay. Now let us take the software, popular CAD software. So we have SolidWorks. We can design the 3D model. Fusion 360. This is the free software for the students for 1 year. We have Tinkercad. We can design the model. And another open source software is what it is a Blender. Okay. Actually, the Blender it is used for the designing the game characters, but we can use this for our model creation also. Then we have the types of the modeling. So solid modeling. Solid modeling represent the entire volume of object, providing a complete and precise definition of its geometry. So that is our solid model. It is of two types: constructive solid geometry and boundary representation (BREP). Where we can use this solid modeling. So we can use for developing the models for engineering and for manufacturing purposes, where precise dimension and physical properties are essential. Okay. Then so where we can use this which type of the software we can use? SolidWorks, BTU, Creo, Autodesk Inventor, Siemens NX. So this can be used for developing the solid modeling. The second type of the modeling, 3D modeling, it is called as the parametric modeling. The parametric modeling is a modeling process with the ability to change the shape of the geometry as soon as the dimension value is modified. So this is very important. So, okay. So if at some stage of the development of your 3D model, if you want to change the some value, so there will not be the same effect will be implemented on the other dimensions also. So that is part of the parametric modeling. Okay, that means if I change here 1 mm, so the other geometry will remain unaffected. Okay, the other dimensions will remain unaffected in parametric modeling. Later stage, if I want to change this 1 mm to 5 mm, so this will increase, but this will remain same. So, okay, so that is called the parametric modeling. So these are the two techniques are there: feature-based modeling and constraint and relation. This can be used for design of mechanical designs. Okay, product design, system and design iterations are frequent. So in that case, we can go for the parametric modeling. The popular softwares are SolidWorks, Fusion 360, PTC, Creo. Then the one is the preform modeling. Preform modeling means what? It focuses on creating the complex and organic shape using the sculpting and the deformation tools. Okay. Generally, this is used for character designing, character modeling, or aesthetic or ergonomic designs are there. So using that means the freeform modeling, we can give the shape to that particular we can give the shape to the initial shape. Okay. It is just similar that we are using the that we have these that soil, and we are creating certain the models from using the sand. Okay, so that is called as the preform modeling. Okay, then what are the introduction to computer aided design software and its role in 3D printing? So design creation. So CAD software allows you to create a 3D model. So that is we have discussed. CAD software provides tools to create precise and accurate design, ensuring that the printed parts meet the required classification. Design optimizations. So at any stage we can change the geometry, or it also offers simulation tools to go under to test the design under various conditions such as stress, heat and motion. This help in optimizing the design before the printing. Okay. Weight reduction. CAD software can be used to optimize the design for weight reduction by getting lattice structures or hollow parts without compromising the strength. And the last part of this 3D modeling software is what it is file exporting. So for the 3D printing, we require the STL files. Okay. So from 3D printing, 3D modeling software, the model can be transported as STL files. Okay. G code. Some CAD program also generates the G code, which is a language used by the 3D printer to control the printing process. So finally, these STL files, these are composed of the G codes. Using these G codes, our 3D printer prints the 3D model. Design modification and customization. So if you have any iterative design, so at any stage we can make the modification. This is particularly useful in iterative design process where multiple versions are tested and redefined. CAD allows for the customization of the parts to meet specific requirements, making it ideal for creating the tailored products. Collaboration and sharing. So in the cloud the CAD, now every 3D modeling software, it is a cloud based. Now you can share your model with your friends or any expert, and they can modify that particular model from any location. Okay. And the documentation, the CAD software also provide the documentation. That means whatever you are doing from the step one to the end step, you will get all the documents related values in the form of the documents. Okay, so that is possible in the CAD software. Now this is the again the flow of how we are the preparing the files for our the 3D modeling software. First is the CAD modeling. So prepare your 3D model using the 3D modeling software. File preparation. So export that file in the form of the STL files, and then take it to your 3D printing software. Okay, so these are the three steps are there. Now once you are ready with when you are ready with the software, so once you get your 3D printing the STL files, so what you have to do, then we have to go to the 3D printing software. So this is the 3D printing software is there. Now when you load certain material here, so this is the STL file. So suppose this is the 3D okay, so this is your this is the file. Okay, and now when you start slicing, so these are the different types of the parameters are there. So all these parameters we have to set in the 3D modeling softwares, and then finally we'll get the file, the export of file from this 3D printing software for our 3D printing. Okay, before that, what we have done, we have generated our the 3D model. So let me show you that one also, and then we have export that in the form of the STL files. So file preparation. So this comes in the form of the STL files, STL file. Okay. So we will take that file here. Let me show you the 3D modeling software. So I'm using the you can use any type of the 3D modeling software. So Autodesk Fusion. So it is freely available for the students. So you can take that. We can download that the Autodesk or the Fusion 360 files. You can download. Okay, so how to create a geometry? So it is very simple. So here, let me show you how to create this cylinder, something like this, and then uh, so like this, and then okay. So some such like this, we can create a 3D model here. Okay, using this Fusion 360. Now once you create any 3D model here, okay, so what we have to do now, we have to export this 3D model. So here this is 3D print is there, okay. So 3D print, then here it is export, okay. Now you see here, this is format is what it is, STL. So you have to select this 3D, 3D your 3D 3D model, STL. Unit type is the millimeters, and then you have to click here OK. Okay, so then you have to give here the name. Suppose this is cylinder, and then your file is it is exported as the STL file. Now where you have to save it. So I'm saving this into the downloads. Let us save here cylinder.stl and then save. Yes. Okay. Now what we will do, we will I will delete this, and so STL file. So this is 3D. What we have done, we have generated the 3D model. So this is the first step. We have exported in the form of the STL files, and now I am taking that into the 3D modeling software. Okay. Okay. So now I am importing that file here. So cylinder, and so now see your file is here now. Okay. And then from start slicing, now you can add the number of parameters here. Okay. So we will discuss this number of parameters into the coming slides now. Okay, let us now slide this one. We are doing now the slicing. So this is for the slicing. That means we have divided this the total model into number of layers. So that layers you can watch here, something like this. See, so these are your layers. This is 0, and now this is layer by layer. Now it is completing the object. Okay, your cylinder build like this. Okay, so this is regarding the formation of the files using this the software. Okay, so now onwards we will discuss the different types of the parameters, okay, in the next video.